Welcome to the video on 25CS210, Internet of Things. We are starting with Learning Unit 1, which focuses on the foundations of networks and IoT architectures. Key topics include IoT concepts, components, communication fundamentals, and protocols. The major components of IoT include the thing or device, gateway, cloud, analytics, and the user interface. These components interact via a wireless network and data exchange. IoT components are divided into hardware and software. Hardware includes sensors, actuators, microcontrollers like Arduino and 32 Spanish pesetas, and gateways like Raspberry Pi. Software consists of firmware, cloud services, APIs, and analytics engines. Let's begin with a warm-up question. What is the simplest sensor you have noticed in daily life that reacts to its surroundings? Sensors are input devices that detect physical, chemical, or environmental changes and convert them into electrical signals for a microcontroller to process. They measure real-world parameters, convert signals, and enable automation. We have various types of sensors, including environmental sensors like temperature and humidity, PIR motion sensors, electrical sensors for current and voltage, and specialized sensors for soil moisture or heart rate. Sensor types include environmental, motion/position, and imaging sensors. Key characteristics are accuracy, sensitivity, range, power efficiency, and response time. The role of sensors in IoT is to provide raw data input for processing and decision-making. Examples of their use cases include smart thermostats, health monitoring wearables, and industrial automation. Actuators are the hands and voice of IoT. They take decisions from microcontrollers or software and turn them into real-world actions like movement or sound. A buzzer in a school bell is an example. Actuators are output devices that convert electrical signals into physical action. They perform actions based on processed data or commands, controlling mechanical or electrical systems to enable automation. One type of actuator is the hydraulic/pneumatic actuator, which uses fluid-based control. In IoT, actuators convert digital signals into physical actions, such as switching lights or moving robots. Use cases include smart locks and irrigation systems. A microcontroller is the tiny brain of IoT devices, combining a processor, memory, and I/O ports on a single chip to control sensors and actuators. The chip in a TV remote is an everyday example. Microcontrollers are small computing units that control sensors and actuators. Popular boards include the beginner-friendly Arduino Uno and the advanced ESP32 with built-in Wi-Fi and Bluetooth. Their functions include processing sensor data and communicating with gateways. The IoT microcontroller market is showing significant growth, with trends indicating rising demand for automotive MCUs. Industry drivers include the need for increased connectivity through 5G deployment. Key characteristics of microcontrollers include processing power, connectivity with built-in Wi-Fi and Bluetooth, expandability through shields, and ease of programming. They provide local intelligence and device-level control in IoT. Next, we look at IoT gateways. A gateway is the bridge of IoT, connecting local devices to wider networks or the cloud. It handles protocol translation, security, and data routing. Gateways are intermediate devices that connect IoT nodes to the cloud or wider networks. Examples include Raspberry Pi, which is affordable and flexible, and industrial hubs, which are rugged, high-performance gateways. Gateway functions include protocol translation, such as Zigbee to Wi-Fi, data aggregation and preprocessing, and security enforcement. Their role is to bridge local devices and cloud infrastructure. We have now discussed all hardware components: sensors, actuators, microcontrollers, and gateways. Next, we move on to the software components: firmware, cloud services, APIs, and analytics engines. Firmware is stored in non-volatile memory and runs every time the device powers on. It performs tasks like initialization before the application layer runs. Firmware is low-level software embedded in microcontrollers and sensors. Its functions include controlling hardware, providing communication drivers, and ensuring device stability. It acts as the operating system for IoT devices. Cloud services are platforms that store, process, and analyze IoT data. Examples include AWS IoT Core, Azure IoT Hub, and Google Cloud IoT. They offer centralized intelligence and scalability. APIs are interfaces that allow communication between IoT devices, applications, and cloud services. They include REST APIs and MQTT APIs, and their role is to facilitate integration across diverse systems. Analytical engines are software tools that process IoT data for insights. They enable real-time monitoring, predictive analytics, and visualization dashboards, transforming raw data into actionable intelligence. The DHT11 is a widely used beginner sensor, and the ESP32 is a favorite microcontroller due to its built-in Wi-Fi and Bluetooth. IoT gateways, like Raspberry Pi, can run full Linux stacks. In summary, the hardware components of IoT include sensors, actuators, microcontrollers, and gateways. The software components are firmware, cloud services, APIs, and analytics engines.